This lesson is about declaring variables of the fundamental data types. It's easy to do, and you can do it anywhere you want in the program. I wrote this simple class to demonstrate just how it's done. This class doesn't do anything, but it does compile. There are some access declarations, private, public, static, and so on, and I'll get to those later. Right now, I just want to show you the basics of declaration. The first declaration is of an integer, x. That's all there is to a declaration. You name the type, then name the variable, and follow the whole thing up with a semicolon. Now, x is declared inside the class definition, but it is declared outside of any method. So, it's accessible from any method in the class. Also, when you build an object from the class, each object will have a copy of x. Any value that any object stores into x will stay there as long as the object exists. No initial value was defined for x, so it will be automatically set to 0 whenever an object of this class is constructed. Here's a double value declared basically the same way, except this one is given an initial value. All you do to provide an initial value is include an equal sign and the value. Now, these initial values are usually literal constant declarations, but they can take different forms. I'll be showing you some of these forms later. Here's another declaration. This is a char data type, and it has a character constant declared as its initial value. If it didn't have an initial value, it would be set to the null character, which is a numeric value of 0. Now, here's a declaration that occurs inside a method. This opening and this closing brace define the body of the method itself. The variable limpet is declared inside the braces, so it only exists inside those braces. Actually, it only exists from the point of its declaration down to the closing brace. You could declare it anywhere you wanted inside those braces. Here's a Boolean value that's declared inside the method. The Boolean value is explicitly set to false, although it would automatically be set to false anyway. Sometimes an initial value like this is good to document the fact that your code wants to have it that way. In fact, some Java compilers will flag it as an error if you try to use a variable that you haven't explicitly set. Somebody's personal coding preference worked its way into the compiler, and the error messages, it's usually a good idea, but it isn't actually required by the language. These variables, limpet and switch on, are created every time the method is called, and they are given new initial values every time they are created. If you want something to retain a value between method calls, you'll have to declare it outside the method. Here's another set of braces. Just like the outer body of the method, the things declared inside these braces only exist inside the braces. Now, the variables named limpet and switch on also exist in here because the outer brace scope includes everything inside the set of lower braces. Usually, braces are used to group statements for a loop or a body of an if statement or whatever, but anywhere you put braces creates a block of code and its own scope for its variables. Inside this block, 2 bytes are declared. One is given an initial value, and the other is assigned a value later. The result is the same. The two are then added together, and the total of the 2 values is used as the initial value for the declaration of the sum variable. In this example, as soon as all this declaration and value setting is done, the closing brace comes and closes the scope, and B, C, and sum are all omitted. There is a slight exception in the placement and scoping of declarations in the for loop. Notice that the loop counter I is declared inside the parentheses of the for statement, but not inside the braces. As a special case, anything declared inside the parentheses exists in the parentheses and inside the body of the for loop. It's just as if it were declared inside the braces of the body of the for loop, and once the loop exits, the variables declared inside it disappear. I mean, it's no surprise that the variable I exists inside the braces of the loop, but the exception is that it is made to vanish beyond the closing brace of the loop body. That's really about all there is to declaring fundamental data types. Don't forget there is some access information that can be assigned to the declarations, but the declarations themselves are quite straightforward.